Hello everyone again to my YouTube channel. Today in this session I will continue with Matplotlib package as a basic uh, package for visualization in Python. So today in this session I will show you some visualization with some data, some tricks, and we can use all these things to discover and understand more our data. Well, here in this cell, the first cell, what I see, as we see, sorry, we have all the packages I need for in my session. We have Matplotlib and we have also Matplotlib pyplot here for visualization, and we have NumPy package for computation. I run it. So in the second session, I create four random data based on this package of random and random. That means we have four columns with 100 simple for each one of these four data I have. Well, the first visualization we can that what I can show for you. We have labeling plots here. Well, I try to explain for you this piece of code. Well, here as we see, we have mu and sigma, two variables. So the first value 100 120 is for mu, and we have sigma, we have 15. Well, the idea behind this piece of code is to show you normal distribution based on MATLAB. Well, the second variable we have here is x equal to mu plus sigma times into random rand 100,000 sample of data. Okay, I create this x with this value here 1,000 100,000 point we have here. Well, I create this fig and x equal to plt.c plots 10.57 layout concentrate. Here I create, because if I want to create more than one uh, visualization or graphs, I should use this syntax of cplots. Okay, because cplots, firstly I give for us this ability fixed size. That means we have, if I will to increase size of our visualization or decrease it, that's different of course. Also fill layout here for concentrate to make it more clear. And here we have n beans patches equal to x dot haste x60 density true face color 0 and alpha 0.75. Here is piece of code n is for the x. Okay, n associated with this value of x behind here we see, and we have the pins, the number of pins I have here. We have 16 pins, and for patches is the rest of this piece of code. That means we have density and face color, and alpha is the width of these bars or the histogram we have. Here also for this x.sit x label, this is the title of x-axis. We have here the length by centimeter, and for y-axis we have probability, and title of this graph or this visualization is normal distribution. Okay, I give for here a title to show you more, give us the idea about uh, give us the idea about this visualization. Here also we have text. If I want to include the text inside of prompts, I can with Python, of course, or with this Matplotlib package. We have text, the weight of text 75 and 0.025, and we have mu 120, and we have sigma. If we want to include the text inside of my visualization. Also here we have the axis, we have 55 and 175 for x-axis, and we have 0 to 0.03 for y-axis, and I activate also the grid. Okay, I want a grid in background of my visualization. Well, if I run it, this is the result what I can get here. Well, I need to right here. Okay, this is the beauty. Well, here this is our distribution, the normal distribution. This is more of data scientists and data analysis want this visualization when try to plot arrange some variable. As I told before, we included this text here inside of my visualization. Also, we have the grid in background of this visualization. Okay, and we have the title of x-axis and title of y-axis and the big title. Okay, well, let's pass to another one. So also, Matplotlib provide for us annotation. That means I can annotate some arrow inside of my visualization. Well, here also I create two variables fig and axis, and with plot, with cplot also I activate this fig size. I give it some values here, and I create one variable called t equal to np. With help of this function of arrange, I create a range of my data here. Okay, create the variable start from 0 to 5 with step of 0.011, and also I use here a cost function. Okay, and I pass inside of this cost function 2 times in p dot p times t. Okay, times this the range of data I have here. Well, here I create a line equal to x dot plot. I plot this t and I plot also this x with a cost function, and the width of line I want to draw, or the width of line is 4. Okay, and I annotated this text local max here with with xy equal to 3 1. This is the coordinate of this text I want to include, and also the y-axis or y coordinate here with 3 8 1.5, and arrow proposed dictionary. I want this the color of arrow and shrink here. So if I run this piece of code, this is the result what I get. Here local max there is here. Okay, this is xy. That means if I look here in my visualization, we have 3 in x-axis, 3 and 1 here. If I can change it, I can. Okay, if I pass, sorry, I pass here, for example, 2. Okay, if I run again this piece of code, this is the result what I can get. Okay, okay, we have 2 and 1. Okay, and also for the color of a row, if I want to change it, if I will give for example blue. Well, blue, sorry, blue. Well, it will also, if I run it again, so the color of this arrow will be changed to be blue, as we see here in our. Okay, the shrink does mean the weighted of this arrow here. I can change it also. So let's pass to another one. So here also, I uh, I will give you the example of this visualization to show you how we can include our legends inside of visualization. Here I create some plots here based on the data I create here before. Yeah, based on this data. So well, so this is the result what I get. So here I create a range based on this length of data one, and also I pass the data one, the label of data one. Also, I create second one here, the plot with the function of plot. Also, with the help of this function of range, I create the length of data 2, and data 2 and label is data 2. Plot 3 is the array of length data 3, data 3 also, label is data 3. So as we see here, when I run it again, gonna get the same results. So here, as we see in our visualization, we have 3 different data. Each one of these data has its own color and shape. Okay, so data 3 is very different for both other data 1 and data 2. Well, so here the idea behind is to how we can add in the label for our visualization for anyone. It's coming to see this visualization can understand based on this solution we have here. Okay. Also, with Plotline we can use skills. scales. Well, here I create also a vacant axis based on these plots, okay, and they pass this attribute of fixed size here and layout concentrated. X data is a range of line data 1 and 4 data is equal to 10. So here is power of data 2 square data, so it's 10 square data 1 here as a new data. So for axis, or for axis 0 is plot x data and data, okay, x data and data, and for x1 equal to set y score log, and for axis 1 plot x data and data. Well, what's happened here? When I create this data, I log it in the second one. The same data, I add, I scale my data based on the log function. Okay, so this is what happened here. We see the scale is a log. Well, so this is the value here. We pass it. Okay, so here 2016 to 18, 80 to 100. So this is what's happened here. For linear to non-linear scale. Okay, this is the result what you get here. Also, we have here another visualization here based on this function of state time and np.time 64. I create this range of dates based on this date to another one here, and we have time delta 64 by hours, and the data it's the common sum from all this data I create here. Okay, the length of all this data, or length of our dates I create here, and they plot dates and data I created based on this length of all these dates we have here. And we have CML, those this consistent data format here, just for create or to start from this one to a negative one here to come from all these things. Well, if I created here, or I run this data, this is the result what I get. So the idea behind this graphs, or this kind of graphs, is used in finance. Also, Python provide for us this kind of data when trying to see the price and stock in finance. So we can see this, and especially in time series when we have the price and we have the date. So at this time we can see the graph how it is. Okay, we try to make some predictions. Well, at this time we need to see the shape of the graphs of our price or our stocks. Well, also here, Matplotlib Live gives us the ability to plot in some category variables. As we know, in data, we have the categorical variables. That means those variables content string as values. For example, gender in some data in a variable, we can face in some variables like gender. For example, we have two values, can be male or female. At this time, we need to plot in these values. How we can do that? We can use bar plot to measure how much of female we have or how much of female male we have. So in this example, I give you the name of some months here, 4 months. I create again uh, this line, so fig and axis with a C plot. Okay. Also, I create the categorical. We have May, April, June, and July, and I create this bar based on this category we have here. And the result is here. Okay, as we see here, we have May, and April, June, and July here. So that's mean we have the May is more frequent. Some, if we want to visualize this kind of categoricals, we have this ability with Matplotlib here. Okay, so let's pass another one. So here in this code, what I do is I create three dimension variable. We have x and y, which is mesh right function with the line space between -3 and 3. I have 120 element or measure or variables. Also, I create a second one here, and for z, I create this value using the expo functions and x and y variables here as we see. Well, I create this plot also for 2 fixed size layout concentrated here because 2 because like a matrix. I will show you. I will show you now what's happened. Well, I run this piece of code. So for PC we have axis 00 is like a coordinate. So we have P color match X, Y, and Z. This value we have here created with value minimum value here is -1 and maximum value is 1. As image, this value is already red. This kind of color. I put this figure here color bar PX equal to X 0 and 1 and axis 0 1 or 0 0 here. This title is color match. So when I run it, this is one space color match. Here the concentration of colors here does mean we have huge data here. So this is the idea behind this visualization because I create three variables, three dimension. Here I show you uh, how much of data we have here. The concentration of data does mean we have huge data here and here and here. So the colors here we have small like other one. So the same thing with the second one, second variables here. Create counter with three variables, level line space, I pass the line space here with specify the interval. So using this fig color bar also, I have seal is what I create here based on this axis. If we look at here, the axis, the position is different. We have 0 here and 0 here, that's mean the first row, and 0 here is 0 position, 0 color and 0 row. And here we have, so here is different. We have 0 1 0 here and we have 1 here, that means the second column. Okay, we I create the counter if here with three variables I create before and labels based on this line space until we have and pick for color bar cu axis equal x01 the position 0 or row 1 row 0 and a color 1. So I create a title here counter for it. So and the result is here. That's what I see here. Okay, we have the counter for here in this bar show for us the value. So here in this example, if we have a read here, read one or read color here, that means we have huge data. If we have blue one here, the data is negative. Okay, so this is map. So I will show you that before when try to understand the relationship between variables when plotting a huge number of data at this time we can recognize the relationship we have between variables based on this color. If it's high color here with one or blue one here, show us the kind of relation between variables. So the same things happen here. We have a dark blue, or we have with green. Okay, yellow show for us the kind of data we have here. So at this time or at this interval here, we have huge data, and also here is medium, and so on. Okay, so sometimes here with start example here, I applied the log norm. So here we create this piece equal to x on 0 image show this value of z squared times 100 sigma plasma, and we create the norm. We pass it this value of colors of log norm with value 001 and max is 100. and color bar here, the same things with 0 to 1 extend both, and the title is image show with logo norm, and this is the result here. Okay, so all the value we have here, we pass it with log norm here and show us this how much of values we have. If we have yellow color here, this means we have a high scale data. If we have purple here, blue, this means we have low values. So we pass for third one, the last one here is the scatter. So in this position of 1 1, we pass scatter of data 1 and data 2 and is data 3. Okay, and same value here for the color, and color bar so p is x equal to x 1 1 extend to both, and we give a title as a scatter. So and this is the result here. So scatter, we use it to measure the relationship between two variables or more. Okay, well, here this color, this bar will show us how much the relationship we have here. If you have blue one or gray one, okay, or red one or medium, that's depend. If we take in any point here, we can have an idea between, or we can have an idea of the relationship between two axes, x or x and y. Okay, any point here, we can measure the relation and see how it is the relation between two variables or more. Okay, here I show you this example just for show you how MATLAB Lime is also is powerful. Okay, and we can use it to build in real projects. So I will end in the tutorial and see you in the next session. And I hope to understand this kind of visualization and piece of code. And happy learning for everyone again. See you again. Bye bye.